welcome back to my YouTube channel. In this video, I'll be discussing about the unit circle. However, before I watch any further, don't forget to hit the subscribe button so you won't miss any of my videos. And if you do enjoy this video, don't forget to hit the like button and share this link to your friends. So, what is the unit circle? Well, the unit circle is basically a circle located in the center of the Cartesian plane. Let me just make the circle neater. This is going to be the x value and this is going to be the y value. And then the circle is going to have a radius of 1. So its radius is going to be 1. So now let's just define some points. This point will be 1, 0. This point will be 0, -1. This point will be 0, 1. And this one will be -1, 0. So, for this angle, let's just try to make an angle of theta. Well, in unit circle, when you want to make an angle, you will always have to start with this line as your base line. So then, you're going to move of the angle of theta, and then you're going to have a line like this. And then, for the angle theta, when you want to make an angle in the unit circle, you have to move counterclockwise when you want to make a positive angle and clockwise when you want to make a negative angle. So, when you want to make a positive angle, you have to move counterclockwise. And when you want to make a negative angle, you have to move clockwise. So, because I made it counterclockwise, this theta is going to be positive. And now, let's just say that this point is going to be A, B. Which means, if you trace a line down here, it will be equivalent to the y value of this point. And then, the y value is going to be B. And then, this one is going to be A, which is the x value. And then, what if we draw a right triangle based on this information using the A, B, and angle theta? Well, let's just make it in here. The triangle is going to be B, A, and theta. And don't forget, this side is going to be 1, because that's equal to the radius of this circle. And the radius of the circle is 1, as we've stated right over here. And then, what if we want to find out, let's say, sine of theta? Well, we know that sine is opposite over hypotenuse. The opposite of the angle theta is the side B, so it's going to be B divided by the hypotenuse. The hypotenuse is always this line, which is facing the 90 degrees angle. So it's going to be B divided by 1, which is basically B. And then, what about cosine of theta? Well, same thing. It's going to be the adjacent, which is this side, A, divided by the hypotenuse, which is 1. A over 1 is basically A. And then, next, let's just take a look a little bit for the sine and cosine. So the sine is going to be B and the cosine is going to be A. But look, B is going to be the y value of the angle and A is going to be the x value. This is very fascinating. So then, we can say that the angle sine, the sine of the angle, is going to be the y value of the point intersection in the circle. And then, we can say that cosine of the angle is going to be the y value, because A is the x value. And then, it's going to be the x value of the same point intersection. So, why do we study this? Well, because this is going to be useful to extend our knowledge about the trig ratios. Because we can always use trig ratios as a normal triangle in here. However, it can only be applied when the angle theta is going to be smaller than 90 or larger than 0. Because when the theta is going to be 0, there will be no triangle. Because the triangle will have to get a 90 degrees in one of the sides, because it's always a right triangle. But if the angle is 0, a triangle cannot be formed. And the same thing, if we use 90 degrees or more, one of the sides will have to be 90 degrees, right? Because it's a right triangle. But the other side will have to be 90 degrees too. And it cannot be formed a right triangle. And even if we make it larger than 90 degrees like this, it will still not form any triangle. So, the trig ratios that we've been using can only be used when the angle is smaller than 90 or larger than 0. So, what if we want to find out, let's say, sine of negative numbers, cosine of negative numbers, or sine and cosine of angles larger than 90? Well, we're going to use our unit circle. So now, let me just erase some of the things in here to give us more space. So, what if I say that I want to find out sine of negative 30? Well, then let's just make an angle of negative 30. Let me just erase this a little bit. And then, as I said before, if you want to make a negative angle, you have to move it clockwise. So we're going to move clockwise into here, and 30 degrees is about like this. So this is going to be the point intersection. This is going to be 30 degrees, and then we're going to make a little triangle in here. So how will we find it? Well, we know that the sine is going to be the y value, which is this one. However, what if we make an angle of 30 degrees rather than this negative 30 degrees? Well, let me just erase this right over here. So now, let's make ourselves an angle of 30 degrees. So it's going to be about like that. And then, for the sine of negative 30, it's going to be the y value, which is this side over here. However, for the sine of 30, it's going to be this value. And if we look at it, the sine of 30 value in here will be equal to the one in here. However, this one will be positive, while this one would be negative. So we can write that sine of 30 is equal to sine of negative 30. However, the sine of 30 is positive, but the sine of negative 30 is negative. So we can make the sine of 30 become negative, and they will be equal to each other. So, with the unit circle, we can solve for negative angles, just like this one. And then, we're given that negative sine of 30 is equal to sine of negative 30. And this one would always be true, no matter what angle you use. So we can say that sine of negative theta would be equal to negative sine of theta. And we can find this using our unit circle. But what about our cosine of negative theta? What would this be equal to? Well, firstly, let's just erase the triangle of 30 degrees. And then, what if we used, let's say, another 30 degrees for the angle for cosine of negative 30? And then, we can still make our angle that intersects at this point with the circle. This will be negative 30 degrees. However, for cosine, we calculate the x value, which is about this one. And then, what about our 30 degrees angle? It's going to be like this, then it's going to be 30 degrees. Well, the x value will still be equal, because the x value in here is going to be used in cosine of 30 and cosine of negative 30. So we can say that cosine of negative theta is equal to cosine of theta. But what about tangents? Well, for unit circle, it's quite hard to write the tangents in one of the angles. However, we do know that tangent is equal to sine over cosine. So then, tangent is going to be the y value over the x value. So then, what about tangent of negative theta? Well, we know that tangent is going to be equal to sine over cosine. So tangent of negative theta is equal to sine of negative theta over cosine of negative theta. And then sine of negative theta is negative sine of theta, so it's going to be equal to negative sine of theta over cosine of theta. Sine of theta over cosine of theta is tangent, so negative sine of theta over cosine theta is equal to negative tangent. So then we can say the tangent of negative theta is equal to negative tangent of theta. Negative tangent of theta. And then there are lots of other identities that we can find out using our unit circle. Like for example, we know that sine of theta is going to be equal to cosine of 90 minus by that theta. And then other than sine of theta is equal to cosine of 90 minus theta, there are much more. And we're going to go to the depth of it in another video. And then, let's say that we want to find out sine of 75. Wait, let's say 175. What is it equal to? Well, for a sine of 175, the angle is going to be about like this, because it's larger than our 90 degrees. So then this is going to be 175. So, for the sine of it, it's going to be the y value, which is about in here. So, we can just say that this is going to be equal to, if we make another triangle that is symmetrical to this one, and we can find out it's equal to the y value right over here. So, what about the angle of this symmetrical triangle? Well, we know that this is 175, so this angle is going to be 175 minus 90. That's going to be equal to 85. And then, because it's symmetrical, then this one will also be 85. So this angle is going to be equal to 90 minus 85. It's going to be 5 degrees. Or, you can just calculate that this angle is going to be 5 degrees, which is 180 minus 175, which is going to be equal to this one. So then, we can make our triangle with this being 90 and this being 5 degrees. And of course, this will be 1, because that's going to be the radius of the circle. And we can calculate this one with our simple trig ratios. So, with our unit circle, we can calculate angle smaller than 0, like negative angles, using the fact that sine of negative theta is equal to negative sine of theta, cosine of negative theta is equal to cosine of theta, and much more. And for angles larger than 90 degrees, we can just make a symmetrical triangle of it, or use other identities, like sine of theta is equal to cosine of 90 minus theta, and much more. So then, let me just erase this triangle right over here, and let's go through some practice questions for this unit circle. Let's say, for the first number, we're asked to find out sine of 120 degrees. The second one, cosine of, let's say, 150 degrees. And then the third one is tangent of 180 degrees. So, for sine of 120 degrees, we can just make ourselves another triangle, which this one will be 120 degrees. And then, for sine, it's going to be the y value, which is the one in here. And we can still make a symmetrical triangle in here. And this one will be the sine of it. But what will be the angle? Well, because this total one is 120, then this one is going to be equal to 60 degrees. And then, that means that this symmetrical triangle will also have 60 degrees in here. And then we can draw ourselves a triangle with 90 degrees, 60 degrees. And then this means that this angle will be 30 degrees. And then we can identify that this triangle is one of the special triangles which has a certain ratios between the sides. The ratio is the hypotenuse is going to be 1, this side is going to be half, and this is going to be square root of 3 over 2. So for sine of 120, it's going to be the y value of it. It's going to be this side. And then we found out that it's going to be square root of 3 over 2. And then, what about for cosine of 150? Well, let us erase this triangle and this triangle. For cosine of 150, it's going to be about in the second quadrant. It's going to be the first quadrant, second quadrant, third quadrant, and fourth quadrant. And then, because it's larger than 90 degrees, it's obviously going to be the second quadrant. Let's just say that it's going to be about like this, a little bigger than our sine of 120 degrees graph. It's going to be 150, and then this angle is going to be 30 degrees, right? 180 minus 150. So then we can make a symmetrical triangle once again, about like this, and then this angle is going to be 30 degrees. Once again, we can redraw this triangle with this being 90, this being 30. So then this angle is going to be 60. The same thing, this is one of the special triangles which have a certain ratios between them. This is going to be 1, this is going to be half, and it's going to be square root of 3 over 2. It's just like the triangle before, but it's rotated. So then the cosine is going to be the x value, which is going to be the length from this to this, which is basically the base. And the base is going to be square root of 3 over 2. And then, what about for tangent of 180? Well, we know that tangent is sine over cosine. So tangent of 180 is going to be sine of 180 over cosine of 180. And then, what is sine of 180? Well, we're going to go full 180 degrees, and then it's going to be this point. Well, the y value is going to be 0, right? Because sine of 180 is going to go all the way over here, and then if you measure it, it's going to be 0. So it's going to be 0 for sine of 180, and the cosine of 180 is going to go here, but the cosine is the x value. From the origin to this point is going to be -1. Right here, -1. So it's going to be 0 divided by -1, which is equal to 0. So, in conclusion, the unit circle is very useful because it can be used to solve for more than the 0 until 90 degrees questions for trig ratios. And then, there are some properties of it, like sine of 120 is equal to square root of 3 over 2, and sine of negative theta is equal to negative sine of theta. So if you like this video, don't forget to hit the like button and share this with your friends. And also, if you love math, don't forget to check my other videos. Thank you for watching!